kill it off real easily. You can set up self-healing infrastructure that repairs itself if a machine has a problem. I like to practice what I call impatient upgrades. Why bother with a dist upgrade in a virtualized environment? Just spin up a new machine with a new distribution, reprovision it, and kill off the old one. Much, much quicker. And much, much easier. It's very nice. Of course, the key to all of this I want to real briefly mention is monitoring. If you don't know what your traffic is, if you don't know what your resource consumption is, you can't do any of this. And unfortunately, all the monitoring tools really, really suck. I use Nagios, and it's terrible, but it happens to be the best. So you're a room full of Python developers. Help me, please. Please. I think it's also important that we choose tools impatiently. We don't settle for bad tools. WSGI servers are a great example here. We've got a bunch of really good options with a bunch of really good characteristics, and it's very easy to switch between them. And if we've got the right mechanisms in place, we ought to be able to do this incredibly quickly. And you should be looking for tools that have this characteristic. You should be looking at tools that can be obsoleted easily, right? That can be kicked out the door when they don't work any longer and something new brought in. Of course, this applies to sort of your choice of language as well. I think that Brett Cannon, who ran the process of choosing a distributed version control for Python, summed this up really well when he said that, look, if all the other traits are equal, it's perfectly acceptable as a Python developer to choose Python. But of course, the flip side of that is that if they're not equal, you should feel free to look outside your comfort zone. And in particular, this is why I chose Chef as a configuration management tool. I'm not hugely comfortable with Ruby, but it's close enough that I can pick it up and learn it. And more importantly, there's two really good options in the Ruby world for doing configuration management, Chef and Puppet. So I know if one of them pisses me off, I can throw it out and use it again. In the Python world, there's really only one fully baked solution, and it uses XML configuration files, and I'm just not going to. So finally, hubris. Larry describes hubris as excessive pride. But what's interesting about pride is that since we all think we're so awesome, we want to write tools that make other people think we're awesome too. My business partner, Frank, likes to tell people that the way you know you have a great sysadmin is that you come to work one day and you realize you haven't seen him in like a week, maybe 2 weeks. And his office door is locked, and you finally get maintenance to open it up, and there's a little note on his whiteboard, gone to Tahiti until whenever. And you realize, you know what? Doesn't matter. Everything's running. Everything works perfectly. I have everything I need. If a server goes down, I can fix it. I'm perfectly empowered. The flip side of that, has anyone ever had to say something like this to their boss? Well, I fixed the bug, but I don't know how to deploy it. I got to wait. Alex is out to lunch or on vacation. If you're an ops person, this makes developers hate you. So hubris implies that we should make it, as a good ops engineer, we should be empowering everyone we work with to do our jobs for us, and then we can leave and go on vacation. You can fly to New Zealand for a few days and speak at a conference without worrying about the servers that you maintain going down. The major principle here is that nobody's special. You shouldn't have a deployment solution that relies on one person having the keys and knowing how to do it. Anyone at the right level at your organization, I would argue, needs to be able to hit that deployment button. And that's what scripting and configuration management and all these tools let you do. It means that you don't have to know the sort of 12-step dance of putting up a new version of the site. You just need to know, press that button and have it go. I think this is a really important concept for DevOps, because if it's everyone's responsibility to work on operations, that means that everyone needs to be on the same page. There can't be sort of a special person in this sort of everyone works on it environment. That would be like only giving one developer access to the database. It just wouldn't work as a development strategy. So finally, designing for scale. Now, we've all seen, Knuth's quote that premature optimization is the root of all evil. And, this implies, applied to deployment, that we're not going to be the next Twitter, we're not going to be the next Google, so we probably shouldn't deploy to scale. I'm going to run just a little bit over, I apologize for that. But most people don't actually know the rest of this quote, which says that we should forget about small efficiencies 97% of the time, and that most of the time, premature optimization is the root of all evil. In other words, sometimes we should prematurely optimize. You can take this too far. You can say, why should I write unit tests? I don't know that my code is wrong. That's premature optimization. Well, it's the same thing in designing for scale. If designing for scale is hubris, the principle of hubris says we should do it. Why not plan for success? Why not expect success, at least in the 3% where you need to do it? So you don't go out and buy a cluster of 1 million machines expecting to be Google, but maybe you write your software so that if you need to, it's reasonably easy to do. So automation helps you grow when you need to grow. If bringing on a new server takes 5 minutes, you can probably do it fast enough to keep up with your traffic growth. If you avoid assuming that a single server is special and that it can't be rebooted for some reason, I call this sort of n equals 1, then you can easily sort of increase the number of servers that you have. If we choose tools that we can kick out the door when we don't like them anymore, if we're careful about our tool choice to the point where we have a lot of options, if our tools don't scale with us, we can throw them out, we can rewrite them, we can do something from scratch. And again, I just want to sort of stress, I don't really have time to talk about monitoring in much detail, but the thing that ties together all of this stuff is the ability to monitor it well, the ability to know what's happening within your stack. It's not optional. Do you guys follow the Foursquare outage? They were out for about a day because their MongoDB database, when the database fits in RAM, it stores it all in RAM, and as soon as it exceeds, it starts paging to disk. And when that happens, your performance absolutely plummets because it kind of sucks at writing to disk. If Foursquare had a simple graph of their memory consumption over time, they would have seen months in advance when they were going to run out. But because they weren't monitoring it, all of a sudden their performance fell off a cliff one day, and it took them a day to recover. Even the simplest monitoring is better than no monitoring. And nice, complex monitoring will tell you all sorts of things about what your server is doing. Very nice. But we know this, right? We know that we've all been doing performance tuning on our code. We know how to, do insert timings into our code. We know that statistics are important. We know that shared nothing is an important concept for web development. We know that not repeating ourselves is an important thing to do. We're all already operations engineers. This process has already begun. We've already started to learn the lessons that we need to know to be a good ops engineer. And all you have to do to be good at DevOps is to remember the things you already know as a developer. And if something feels wrong in an operations role, that's probably because it is. So I want to encourage everyone, deploy like a developer. Practice the same practices you're used to. Don't repeat yourself. Don't settle for doing the same thing over and over again. Figure out how to automate. Try to treat hardware as a fungible resource. Try to treat hardware as a commodity. Understand that there's no perfect choice and that you should be able to choose tools that get you out of, that let you move on when you need to move on. And remember that no one in your organization is special. DevOps is something that we all have to do. The best way of summing up DevOps is that we're all operations engineers and we're all developers. It's something we all have to take responsibility for, and we all have to learn enough about. Thank you very much. And I believe type